Okay, hey everyone. Today we're going to be going over the mini lecture for discussion number 2. So this week we'll be covering pandas. Um, we have definitely learned a lot of panda syntax in the last week in lecture. Talked about data frames and series, accessing data in different ways, filtering, grouping by string operations, pivot tables, and so much more. So don't worry if it feels like a huge information overload. We're going to get a lot of practice over the next few weeks, and you'll kind of get it all down over time. And you don't really have to worry about memorizing all of it. So some tips to get fluent with pandas. Try it before you like run your code, try writing it out. Like try your best when you write it out. Um, and like kind of run it in your head, so to say, to see if it would work, because that's what you're going to be doing on exams. And it's good practice to make sure you understand the functions properly. Obviously, then you will try running it, and if it doesn't work, you'll change it. Um, Definitely be very open to looking up stuff on like Google, searching up pandas documentation when necessary, because this is a normal part of being a data scientist. You don't have everything memorized. It's not expected that you have everything memorized, so you should be Googling, and it's um, going to be very helpful down the line when you're trying to use things you haven't used before. It's important to be able to read up about them and understand them from documentation. Course notes are also a great resource. You can find those on the course website. Those line up more so with lectures, so it's a searchable notes that you can look at about this content also, and just obviously practice. So we'll do that in homework and discussion as well. I've also just listed some other resources here that you can look at online. The main one I'll talk about right now is the reference sheet. So the Data 100 reference sheet is on the course website also. You can basically look at what reference sheets were given in past semesters for exams. So I'll show like an example here. This is from spring 2024, just the top of the reference sheet. So you can see it has a lot of the functions on the left with descriptions of what they do on the right. So you're not expected to have like everything memorized. Obviously, we can't put entire documentation on a reference sheet, but it should be still pretty helpful, and it's probably good practice to try and do homework and things like that. Using the reference sheet, obviously it can change a little from semester to semester, but most of it will likely be similar. Okay, so now we can jump right in to talking about all the different things we're learning so far. So in pandas, tables are called data frames. And we can think of a data frame, right, as this example over here, this data frame, as a sequence of columns. So these columns are a sequence of them, that's a data frame, and we call these columns series. So one column is a series, second column is a series, and a bunch of series we can put together and make a data frame. In terms of like making a data frame from scratch, we have some syntax here. This is assuming we have, what's it called? Imported pandas as PD. Right? So we're doing pandas.dataframe, and then we're initializing this data frame that we are saving in the variable called farm. Sorry. So here we're using a dictionary that has the column names as the first part and the values of the column as the second part. So here we have crop, and it has, some crops, and it goes on. Then we have a second column price, and these are the values of price. And it's in these, the iconic curly brackets of a dictionary. To be like blunt, we don't normally do this. Usually you're like importing data from somewhere, and you'll see practice of that on the homeworks. You don't normally like type it all out yourself. Yeah. So now that we have the data frame farm that looks like this, there's things you can do with it, right? You can grab certain columns from it. So if we're trying to get the price column, you can use square brackets and then the column name to get the price column. If you do it with just one set of square brackets, you always get a series. If you do it with double set of square brackets, then you actually just get a sub data frame, right? So this returns a data frame, and it would just only have the price column. You don't need to only do the price column. If you do it like this, let's say we had maybe like 5 columns and I wanted to get just crop and price, I could put a comma here and add write another column name inside these square brackets. Okay, so one of the first things we learn once we have a data frame is Boolean filtering. So Boolean filtering is what we use to filter out certain rows of our data frame. And we do this using a Boolean array of true and false values. So we'll just start kind of going through it. This is kind of the general syntax here. Is you would first get a series, right? that represents one of your columns from the data frame using that syntax we just talked about. Then you would compare it with some comparison operator, less than, greater than, you could do less than, equal to, and things like that. And you'd compare it to some value or something like that. So we see an example here, we're getting the price column and we compare it to 1,000. What this will give us, right, if we look at the price column, if we compare this to 1,000, this one is less than 1,000, this one is greater, this one is less, right? So we would get a series of true and false values. So this one would be true, this one would be false, and this one would be true. That's what this farm bool here is holding. It's holding a series, a Boolean series. And so what we can do with this Boolean series, right, the true, false, true series that we have, is we can, if we give a Boolean array or series or something similar, and we put it inside two brackets next to our data frame name, it'll return that data frame with only the rows that are true. Or another way you could say it is filter out the false rows. So if it says false, we just don't include that row. If it's true, we do. So this is the result, right? We only have those two rows that are true, and we don't have this one because it was false. So one note that I'll add here, right, is that there are some additional things you can do with Boolean filtering, right? Here we're doing one thing we're checking, we're doing one comparison. It's probably like the simplest version of Boolean filtering. You can also do like Boolean filtering with and, this would be the and operator, or this is the not operator. This is kind of special for pandas. We use that little squiggly line. So for example, if I wanted to do this, but the opposite of this, like I want to do not this, I could do farm and then, sorry, not farm price less than equal, oops, to 1,000. So sorry, I'm kind of writing on top of stuff here, but this is that same Boolean array we had before. You have to surround it with parentheses before you can use these operators most of the time. So we surround it with parentheses so we can take the negation, right? We can do the not version of this. So it would basically just flip all the trues and falses, right? So if this returned true, false, true, right? Once we not it, then we'll get false, true, false. So that's like one example. If you wanted to do and, you can do the same thing. We would do like farm. We'd have some first condition here in parentheses and a second condition in parentheses. The important thing is the parentheses are required, or you could also do an or instead. Okay. Now we can look at some of the other ways you can access rows and columns. So right over here, we already looked at one way to access columns over here with just the square brackets. We can also access columns and rows in addition, like more specifically using .lock and .ilock. So .lock lets us grab entries by their label. So we have the syntax right here. The first part is the row names and the second part is column names. So we're doing an example here. Label, let me clarify. What's the difference between label and index? So index is most of the time going to just be like 0, 1, 2, 3, versus label can be other things. So the most obvious differentiation is in the column names. So if we look at these column names here, my column names are crop and price, right? So those are the labels, and the index would be 0 and a 1. So that's the difference. Okay, so let's just go back to looking at the syntax. For some reason it's lagging, but if we're looking at .lock, right, we're doing it by label. So in this case, we're looking at the labels 1 and 2, right, for the rows. And then we're using this, what's it called? Colon, right, to get everything. So if you want everything, you can use the colons. This means all the columns. This is like a slice of the rows, 1 to 2. So that would be these two. In this case, where the labels of the rows match the index of the rows, but sometimes it doesn't. So that looks good. So this is one way where you could do with slicing. Another way you could do it is with a list. So for example, if I wanted to just get the price column, instead of doing this, I could do a list with just price in it. So that would allow me to get just the price column using the label of the column. So the important thing here is that you can both limit rows and columns at the same time. ilock is another version of this, but now we're doing it by index. It's basically the same, except like I mentioned, we're looking at indices instead of the labels, like the actual names. So for this, other than that, it's basically saying the only difference here is it's important to note when you do it with slicing, when you do ilock with slicing, the right end is non-inclusive. So to get the same result for both of these, we actually have, or like both of these, these are all three of these are the same. When you do .iloc, you have to go up one index, right, to the third index because it's going to stop right before that. So it'll go 1, 2, and then not include 3. So it's non-inclusive. Okay, the last part we're talking about on this slide is joining data frames using .merge. So I won't go into too much detail about this because we're going to do more of this later in the semester. But we have the syntax here. We can do pd.merge. We have the first data frame, the second data frame that we're trying to merge. How we're merging them is by like some column that they have in common, right? They have like similar values. For example, like some ID number, my student ID number, for example, maybe is in 2 different data frames, and we can make a new data frame that merges these 2 things based on that student ID column. So you can write what that column name is. It might be the same for both, it might be different. And then this join type stuff, like how we're going to join, is stuff we'll talk a lot more about later. Okay, so on to the next slide, grouping with .groupby. So this is a very important function, super useful, and it allows us to group our rows by a certain column. So it's easier to understand when we look at an example, but I'll go over the syntax really quickly. We have the name of the data frame, and then we're grouping by some column name, and then we can aggregate those groups with some function. Okay, so let's look at the example we have been going with, right? The produce data frame. Let's focus first on like the big text here, and then I'll talk a little bit about the small text over here. So we could do produce dot group by type. So if we look, right, this is the whole produce original data frame, and we do dot group by type, we look at the type column and we see we have fruits and vegetables. So we can split up our data frame into sub data frames, which are officially group by objects. So we get a fruit sub data frame and a vegetable sub data frame. And then we can aggregate it. So this is probably the most common aggregator function, .ag, and then you put what function you want to aggregate with, by, or using. And you can basically, you make every group, you squish it all down into one row, and you decide how you're going to squish it down using the aggregator function. So here we specified we're squishing it with the mean function. So we're going to take the mean of the price and the mean of isred, and that's what's going to take, that's what's going to go in the row for fruit, for example. So the mean of these 2 prices for fruit is what ends up in the price here. And that's decided based on the aggregation function that we specify. Now I'll kind of talk a little bit about why I have this here. So you might think, okay, we're doing the mean, right? Okay, yeah, I could take the mean of price. That sounds good. Maybe it's a little weird to take the mean of Boolean values, but hey, it's possible, right? So that's why we have these numbers here. It is possible if we think of falses as zeros and trues as ones. But how would I take the mean of strings, right? And that's a good question because you can't really take the mean of strings, right? It doesn't, like, it would probably error potentially, or it would just do something you don't want it to do. And so it's important to think about that when you're grouping by, and that's kind of what we're thinking about here. What I'm doing here is limiting my data frame. I kind of did it very explicitly that in this small text, I'm taking just the type column, the price column, and the isred column, because I'm not concerned with the crop column, right? In this case, like, I don't want to aggregate the crop column, so I'm just limiting, I'm kind of like selecting the columns I want from my data frame, the ones that I want to be involved in this group by column. So there are a lot of aggregator functions you can use. So this is like the group by object, right? It's what would come after this. This is kind of what goes, or like it's the data frame dot group by, right? This gives you group by objects, so that's this. And then you can do .ag after, like we did here. You can also just directly do .mean, .sum, .first, .last, .filter. We're going to talk right now more about filter. First and last are kind of interesting, actually. Sometimes you don't realize like that you would want to use them, but they are actually useful. Okay, so let's move on to talking about .filter. So .filter also comes after group by, right? It's another thing you can do with group by objects. And in this case, what we're doing is we're filtering entire groups. So we're deciding if we're going to keep entire groups in our data frame. We take in a data frame, produce, we group by type like we did before, and then we filter. And inside the filter, right, we have a filter function. This function, here we're using a lambda to write the function in one line. And the filter function takes in a data frame, right, which in this case, right, it will end up being a group by subframe. And it outputs one Boolean value. If it's true, we keep the entire group. If it's false, we do not keep the entire group. Importantly here, right, we're not aggregating. We're not squishing the group down. We're just deciding if we keep the entire group or not. So here we can see we're checking if the price mean of the group is less than 200, then we'll keep it. If the price mean is not less than 200, we won't keep it. So here, the mean price of vegetables is less than 200, but the mean price of fruits is not. So we only keep the vegetables. And you can see, right, we have every row in the vegetable group is kept, and we got rid of all the fruit rows. And important to compare here, right, we're not aggregating. We're not squishing the vegetables into one row like we did when we did the .ag. We just keep all the rows. Okay. So let's look at this last thing here, pivot tables. This is what we use when you want to group our data by 2 columns and not just one. So we can group by both type and is red, for example. This will allow us to kind of look at the data grouped by both these things at once. So here we would have, right, 4 different aggregations we're looking at. One is fruit that are not red. Then we have fruit that are red. Then we have vegetables that are not red and vegetables that are red, right? So we're able to group by 2 columns. Let's look at the syntax here. Pandas.pivottable, and then we give it what data frame we want to use, produce. And then we tell it what we want on the rows. So that's the index, which would be type in our case. Columns tells us what we want on the columns. So that's is red in our case. And then we tell it what we want to aggregate by, what we want to fill the inside of our table with. So we're filling it with price-related aggregation. How are we going to aggregate it? We tell it with the ag func. So we want to aggregate with sum in this case. So we here have the sum of all prices of fruit that are not red. Here we have the sum of all prices of vegetables that are red, right? So that's how we fill this up. And you'll get practice with this on the homework. All right, let's move on to the last slide here. I know a lot of content we're talking about today. This is, we're going to talk about the .stir accessory. Right? This allows us to perform operations on a series of string data, right? It lets us manipulate every single string. So if we're, for example, looking at the crop series from the produce column, from the produce data frame, we have strings, right? The name of the crop. We can do something to every single string at once using the .stir. So if we can use any string function that you would normally apply to a single string, we can apply to an entire series of strings using this. So let's look at this example here. This is the general syntax. And we'll look at this example. We have the produce data frame. We're getting the crop series from that data frame. We're putting the .stir accessory, and then we could put any string function we want. So starts with is an example of a string function that we could that returns a Boolean. And now we want to apply this to every single string in the crop series, and we just do that using the .stir. So here we could see, right, starfruit and sweet gemberry do start with S and the other ones don't. So this can be very useful. There's tons of different things you can do with .stir, right? Really any string function we can do .split, .contains, .starts with, .slice. We can do literal slicing like you would normally do on a string. But all of this would have to come after .stir though. Anything you normally do on a string, if you're trying to do it on the whole series of strings, you got to use .stir. So there are a bunch of other functions, right, that you can use when you're doing things in pandas. There's really so many that I'm not going to read them all, but this is for your reference. You have access to the slides. A lot of them will be useful throughout our homeworks, projects, exams. So it's just good to read up on them, and a reminder that you have the reference sheet, right? So use this reference sheet, and best of luck. Have a good time in discussion.